Today, we're going to pull back the curtain on how pretty much every app, game, and website you use actually works. We're diving into the absolute fundamentals, how a program stores, remembers, and works with information. Let's get right into it.
So here's the big question. When you play a game and it remembers your high score, or you type your name into a website and it says, "Hey, welcome back," how does it do that? It kind of feels like magic, right? Well, by the end of this, you'll see it's not magic at all. You'll know exactly how the trick is done.
To answer that, we first need to get a look at the blueprint. Before a program can remember anything, we've got to understand the surprisingly simple way it actually thinks and follows instructions.
And that's really it, seriously. It's not this big chaotic mess. It's just a super orderly process. Think of it like a recipe. The computer reads the first instruction, does that thing, then moves on to the next line, and the next, always from top to bottom. This simple, step-by-step flow is the foundation for everything a computer does.
Okay, so a list of instructions is great, but it's kind of useless without something to work on. You can't just tell a computer add, you have to tell it add these things. And in programming, these things are the raw materials of our code. We call them values.
A value is just one single, tiny piece of information. It could be the number 10, it could be your name, or even just a simple true or false. These are like the basic atoms that our entire program is built from.
So what's the simplest way to get one of these values into our program? We use something called a literal. And the name says it all. You are literally writing the value right there in the code. There's no mystery. What you see is exactly what you get. And this right here is a perfect example. That number 5, that's a numeric literal. And the text, hello, wrapped in those quotes, that's a string literal. We've just handed our program 2 different pieces of raw data to work with, plain and simple. But just having raw materials isn't quite enough. You can't just leave them lying all over the place. We need a way to store them, to label them, and to use them again later. And that's where our smart containers come in, variables and constants. A variable is basically just a labeled box where you can store a value. The most important thing to remember is right there in the name, variable. The value you put inside that box can vary. It can change at any time while your program is running.
Let's look at this simple line of code. Score equals 100. All we're doing is telling the computer, hey, create a box for me, slap the label score on it, and then put the number 100 inside. Now, whenever we need that number, we don't have to remember 100, we just ask for whatever's in the box called score. Now this is where variables get really powerful. This slide breaks down one of the most common things you'll see in all of programming. Score equals score plus 1. So here's what happens. First, the computer goes to the score box and looks inside to see what's there. Right now, it's 100. Then it does the math, adding 1 to get 101. And finally, it takes that new result, 101, and puts it back into the score box, overwriting the old value. That is exactly how a score in a video game goes up. But what if you have a value that you absolutely do not want to change, ever? For that, we use our other type of container, a constant. It's also a named box for a value, but with one huge difference. Once you put a value in it and shut the lid, it's locked. That value is now fixed.
So why would you ever want this? Well, think about something like a tax rate. That number is critical for all your financial calculations, and you definitely don't want it to change by accident somewhere else in your program. By storing it in a constant, we make our code way safer and more reliable. We're essentially telling the computer, hey, this value is super important and must not be messed with.
So here it is, side by side. It really boils down to this. Variables are for your dynamic data, stuff that needs to be updated, like a player's score or a username. Constants are for your static data, things that need to stay put, like the rules of the game or a fixed setting. One gives you flexibility, the other gives you safety. Now, there's one special kind of variable worth knowing about, the global variable. You can think of it like a public announcement board for your whole program. It's a variable that any part of the code, from the very beginning to the very end, can see and change.
A game score is the perfect example. You might have one piece of code for when you defeat an enemy, another for when you collect a power-up, and a third piece that just displays the score on the screen. All of them need to look at and update the same score. Making it global makes sure everyone's on the same page. Now, while they're useful, programmers tend to use them carefully because if any part of a huge program can change that value, it can sometimes be tricky to track down bugs.
Okay, so we've got our containers, our variables and constants, but how does the computer know what kind of stuff is inside the container? Is it a number we can do math with, or is it text? For that, every container needs a label, and these labels are called data types.
And trust me, this is so important. The data type tells the computer two key things: how much space to set aside to store the value, and what operations you're allowed to do with it. It's what stops the computer from trying to say, multiply your name by your age. That doesn't make any sense, and the data type is what enforces those rules and prevents errors.
Now, there are a bunch of different data types, but you're going to see these four all the time. An integer is just a whole number, positive or negative. A real, which you might also hear called a float or a double, is for any number with a decimal point. A string is just for text, and you'll always see it wrapped in quotes. And finally, a Boolean is the simplest of all. It's like a tiny light switch that can only ever be true or false.
All right, we have covered a ton of ground, but you've stuck with it. Let's just quickly recap the core building blocks that we've put together here.
So let's put it all together. At the heart of it all, programs are just a sequence of instructions read from top to bottom. Those instructions work with raw data, like literals written right into the code. We store that data in our smart containers, flexible variables for things that can change, and lockdown constants for things that must not. And finally, every single piece of data gets a label, a data type that tells the computer what it is and what we're allowed to do with it.
And that's it. That's the secret. Every single piece of software you've ever used, no matter how complicated it seems, is built using these simple ideas. You now understand the basic language of how a program thinks and remembers. So the only question left is, what are you going to build with these blocks?